All right, let's jump right in. Today, we're talking about a book that, and this is no exaggeration, pretty much built the modern world. It's a text that completely changed how we think, how we build, and really how we understand reality itself. We are talking about Euclid's Elements. So just how big of a deal is this book? Well, this quote says it all. It's not just that it's ancient, it's the world's oldest continuously used math textbook. For literally thousands of years, if you were learning math in the Western world, you were learning it from Euclid. It's just that simple.
And when we say continuously used, we're talking about a serious stretch of time. The Elements was put together around 300 BCE. That's more than 2,300 years that this one book has been shaping the human mind. Think about that. It's older than Christianity, older than the Roman Empire in its glory days. It's just ancient.
But its age isn't even the most incredible part. The real power of the Elements, the reason we can say it built worlds, is the revolutionary idea at its core.
This gets to one of the biggest questions you can possibly ask. How do you actually know something is true? How do you build a system of knowledge from the ground up where you can be absolutely certain of every single step? I mean, where do you even begin? Well, Euclid's answer to that massive question was just brilliant in its simplicity. He figured that if you want to build something that will never, ever fall down, you have to start with a foundation that nobody can argue with. A foundation of simple, solid, totally obvious truths.
And he starts with the most basic idea you can imagine. Definition number 1, a point. So what is it? A point is that of which there is no part. It's just a location. It has no size, no dimensions, no substance. You literally can't get any more fundamental than that.
Okay, so you have this idea of a point. What's next? A line. And a line is simply a length without breadth. He's just introduced one dimension, length, but he's super careful to say it has no thickness. He is literally building our reality from nothing, one tiny logical idea at a time. And check this out. You can see the original Greek right here. Look how clean and precise that is. There's this beautiful simplicity to it. This isn't some flowery philosophical argument. It's the cold, hard, elegant language of pure logic.
So this brings us to his secret sauce, the big idea. Now we call it the axiomatic method. It's a 3-step recipe. Step 1, start with super simple definitions, like point and line. Step 2, lay out a few postulates. These are rules so obvious you don't need to prove them. Stuff like, you can draw a straight line between any 2 points. Then, step 3. Once you have that tiny, rock-solid foundation, you use pure logic to prove hundreds of way more complex ideas, which he called propositions.
And when you apply that method, boom! An entire complex universe of geometry just logically unfolds right in front of you, all from just a handful of simple rules.
Every single truth in the Elements is proven, step by step, using only the things that were proven before it. Each proof is like another link in a perfect, unbreakable chain of logic. He just keeps building, one on top of the other, proving hundreds of these propositions, eventually getting to huge ones like the famous Pythagorean theorem.
And the amount of ground he covers, I mean, it is just staggering. Over 13 books, he systematically builds our whole understanding of space. He starts with the basics of plane geometry, lines, angles, circles, but he doesn't stop there. The later books jump into 3 dimensions, proving all the properties of solid shapes, and he finishes with this beautiful construction of the 5 perfect shapes we call the Platonic solids. But here's where it gets really mind-blowing. Euclid realized this powerful method wasn't just for shapes and space. You could apply the exact same logical blueprint to the world of numbers. So, in books 7 through 9, he turns his logical toolkit away from geometry and points it at numbers. He basically invents number theory. And right here, we're looking at the very first formal definition of a prime number, a number that's only measured by a unit alone. Today, we'd say it's only divisible by 1 in itself. This one idea is the bedrock of so much modern math and, get this, all of our digital cryptography. He also got into these strange and beautiful ideas like perfect numbers. A perfect number is one that's equal to the sum of its own parts, or its factors. So take the number 6. Its factors are 1, 2, and 3. And what happens when you add them up? You get 6. It's perfect. It's this kind of weird, elegant pattern in numbers that mathematicians still get excited about today. And that brings us to what is maybe the most important takeaway of this whole thing. As amazing as all the geometry and the number theory is, the real legacy of the Elements isn't what Euclid proved, it's how he proved it. It was the method, the way of thinking itself, that completely changed the world.
See, for almost 2,000 years, everybody just assumed Euclid's system wasn't just a system, it was reality. His starting points, his postulates, were seen as undeniable facts about the universe. But then, in the 1800s, some mathematicians started asking a really powerful, kind of dangerous question.
They took one of his self-evident truths, the one about parallel lines, and they asked, what if it's not true? What if parallel lines can meet somewhere, way out at infinity? By changing just that one starting assumption, they built whole new geometries that were perfectly logical, worlds where the angles in a triangle don't add up to 180 degrees. And it turns out, these bizarre new geometries were exactly what Albert Einstein needed to describe how gravity works in our own universe.
So what does this all mean? It means Euclid's method, starting with basic assumptions, or axioms, and building a system with pure logic, it became the blueprint for modern thought. It's not just math. It taught scientists like Newton and Einstein how to think. It shaped philosophy. And that exact same system is the absolute core of all computer science today.
Which leaves us with this final, really fascinating thought. Euclid gave us a toolkit for building whole logical universes from just a few simple starting points. But maybe by accident, he also showed us that the biggest breakthroughs happen when we dare to question those starting points. So, what are the obvious, self-evident assumptions that we all rely on today? And what incredible new worlds are just waiting for us to discover if only we have the courage to question?